Okay, so completing the rest of these, okay, we have a times 4 here. So this must be a times 4 as well. So we end up with 20 here. Okay, here we have a divide by 4 this way. So I'm going to divide by 4 here. And I get 1. Now some of you may have done it in this direction and said, well, this is a times by 4. That's perfectly fine as long as you're doing the opposite in the opposite direction. So again, here I'm going to show it as divide. So divide by 3, divide by 3. So I get 5 over 4 as an equivalent fraction. Times 4, times 4, so 8 over 12. This is a times 2, times 2. We get 6 over 8. And again, it's really, I want to stress again that I want to see these multipliers and multiplying factors or dividing factors. Okay, this one I'm going to do in this direction and say times 6 instead of divide, but I'm going to then divide by 6 to go from 6 to 1. Okay, so here I can do the opposite. I can actually just show it as divide by 3 and do the same direction, divide by 3. Okay, we get that. Okay, so here's times 4, times 4. So we get 4 over 24 is equivalent to 1 over 6. And here we have a times 5. So we need a times 5 here. So 15 over 40 is our equivalent fraction to 3 over 8. Okay, so we need to scale the top and bottom, the numerator and denominator, same proportion. Remember, it's times and divide. Fractions are all about times and divide. So we're not going to add the same amounts to get to the other side. Okay, so for example, here, this is the wrong example, by the way. I can't do like minus 8 and say that's 9 over 12 is equivalent to 1 over 4. It doesn't work that way. This is all about times and divide. Okay, we need to understand that fractions and ratios and proportions are all about times and divide. So there's my divide factor. There's my divide factor there.